Alright, Algebra 1 students, here's our second lesson of the week. Second and last lesson of the week. We have 9.6, the quadratic formula, and the discriminant. So, you'll see many textbooks write this as negative b plus or minus square root of b squared minus 4ac over 2a. The way I like to write it is like this. X equals negative b over 2a. So remember that this formula here, negative b over 2a, is the axis of symmetry as well as the x value of the vertex. So I kind of like to separate that out into, here's one fraction, and our second fraction is going to be b squared minus 4ac over 2a. The reason I like to write it in this manner is because oftentimes we can reduce this fraction and we can reduce this fraction here. What happens if we only write the 1 2a here, a lot of students will reduce this fraction but then forget to reduce this fraction, so it gets confusing. So I just really prefer if you write it as two separate fractions so you don't make any careless errors in reducing. So as we look to this equation here, 2x squared plus 3x minus 5, this is based off the standard form of a quadratic equation, which is ax squared plus bx plus c. And sometimes it's y equals here. In this equation, when we're using quadratic formula, we're just going to say equals 0. So realize, as we go through this here, the a is this 2. So they're identifying the a, b, and c here. And then that 2 goes into the formula where the a's appear in the formula, there and there. So as we look on and we look for the b, the 3 is in the b position right here, so they're just identifying b equals 3. The 3 is put into the quadratic formula in those two spots. And then we have the c. Always remember to grab that sign in front. It's easy to miss those negatives, and of course you get the wrong answer if you miss it. So just be careful and grab that sign as well. So that negative 5 is here and repeats in the quadratic there. So if we look at what's underneath the radical here, remember this square root right here is also called a radical. We can just do the math that's under the square root here. So 3 squared is 9, so I'm just going to begin to rewrite this equation. So we have negative 3 over 2 times 2, which in this case is 4, plus or minus the square root, beautiful straight line, I know, of 3 squared, which is 9. And then if we multiply negative 4 times 2 times negative 5, the negatives are going to cancel because a negative times a negative is a positive. 4 times 2 is 8, times 5 is 40. So it's going to be 9 plus 40 here. Again, over the 4. So if we continue on with this problem, we're going to get x equals negative 3/4 plus or minus the square root of 49 over 4. Square root of 49 is 7, so we have negative 3/4 plus or minus 7/4. So when you have two fractions like this, what we can do is then go ahead and add the numerators. Remember, when we add two fractions, you never add the denominators, you only add the numerators. So I'm just going to go ahead and rewrite one of these equations with the plus and one equation with the minus. Actually, let's hold off on that second x. So we have negative 3/4. I'm going to extend that fraction bar over and write the plus 7. So we have negative 3 plus 7, which equals 4. You can again think of it as 7 minus 3, which makes it a little bit easier to do. So 4 over 4, which equals 1. So I did the plus here of the plus and minus. Now we're going to move on and do the minus portion of the program. So we have negative 3 minus 7 over 4. Negative 3 minus 7, remember again, when we're adding two negatives, add the numbers and keep the sign. So we end up with negative 10 over 4, which reduces to negative 5 halves. So our two answers here are 1 and negative 5 halves. Okay? So there's our first problem with quadratic formula. Moving on to the second problem, we have x squared minus 8 equals 2x. So if you look at this problem, we have an issue because this x term, or the b term, is not in the correct spot. So we need to move that 2x over to this side. The way we do that is by just subtracting 2x from both sides. So we just get x squared minus 2x minus 8 equals 0. Okay? Again, we want this general, or this equation here, x squared minus 2x minus 8, to look like the general form of a quadratic, ax squared plus bx plus c equals 0. So here, if we identify a, we get 1, b equals negative 2, and c equals negative 8. And then we're going to plug into the quadratic formula. I recommend writing that quadratic formula a bunch of times. Even though we are in this crazy online environment here for the foreseeable future, you're still going to have to memorize these formulas for years on that you're taking math classes. This is a formula we expect you guys to memorize. So we have negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. So we're going to plug in the a, b, and c terms into this equation. So if we look up here, we have negative 2. We also have negative b. So remember, you need to have both of these negatives, the negative in front of the b and the negative in front of the 2. Give myself a little more space here. Not quite that much. So we get x equals negative 2 over 2 times 1 plus or minus the square root. Remember, it's b squared, so whenever you plug a negative number in, make sure you use parentheses. If you don't, you get the wrong answer. So negative 2 squared minus 4, a is 1, c is negative 8, and this is all going to be over, let's try that line again, that was a little too crooked. So we have negative 2 squared minus 4 times 1 times negative 8, again over 2 times 1. So these negatives cancel. We have negative 2, which makes a positive 2. So x equals 2. 2 times 1 is 2, plus or minus the square root of negative 2 squared is negative 2 times negative 2, which is positive 4. And then here the negatives are going to cancel because a negative times a negative is a positive. So 4 times 1 is 4, times 8 is 32. So this is going to be plus 32. And then down here, 2 times 1 is 2. So 2 divided by 2 is 1. So x equals 1 plus or minus 4 plus 32 is 36. So we have square root of 36 over 2. A mistake students tend to make here is they'll divide 36 by 2. The reason you can't do that is because there's no square root in the bottom. So you have to square root the number in the numerator first, and then you can divide by 2. So we get x equals 1 plus or minus square root of 36 is 6 over 2. So here we have x equals 1 plus or minus 3. So remember, we have 1 plus 3 and 1 minus 3. So we have x equals 1 plus 3, and we have x equals 1 minus 3. 1 plus 3 is 4, 1 minus 3 is negative 2. So again, our two answers are 4 and negative 2. Moving on to the next slide. Here we have x squared minus 4x equals 21. Again, we're trying to make it look like ax squared. Sorry about that. Ax squared plus bx so ax squared plus bx plus c. Sorry about that. Some minor technical difficulties. So I learned how to use this Moby board. So again, our c term here is on the wrong side. So we take care of that by subtracting 21 from both sides. And remember, we need the x squared term first, then the x, and then the number part. Okay, when we write that in order. So we end up with x squared minus 4x minus 21. Okay, so remember, there's no number in front here, so it's always got to be a, I heard you all say it, it's got to be a 1. So a equals 1, b equals negative 4, and c equals negative 21. Then we're going to plug into the old quadratic formula. I'm going to write that one more time. Again, the more times you write it, the more likely you are to remember it. So negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. So plugging in now, again we have that same situation we had in the last problem where we have two negatives. So make sure you write both of those negatives. We have negative 4 over 2 times 1, which is 2, plus or minus the square root of b squared. So negative 4, again remember to plug that negative 4 into parentheses, because that means we're going to multiply negative 4 times negative 4. If you don't use the parentheses, again you will get the incorrect answer. So minus 4, the a term here is 1, so 4 times 1 times negative 21 over 2 again. And we're going to go through and simplify. So we have x equals negative times a negative is positive. So 4 over 2 plus or minus. And then we'll simplify what's under the square root. So if you want to get your calculator out, we can go ahead and plug that into the calculator. So if I flip back to this, I want to put in negative 4 squared minus 4 times 1 times negative 21. So I'm going to throw that in. So we're going to do parentheses, negative 4 squared minus 4 times 1 times negative 21. So I like to do that. What we just did is, you'll learn later in this lesson, we're plugging in the discriminant. So the discriminant is the part of the quadratic formula that is underneath the radical, which is right here. This part's called the discriminant. So we're going to learn what that means and the implications different numeric values have for that discriminant. But That'll be later in the lesson. So if we have negative 4 squared minus 4 times 1 times negative 21, we get 100. So it's a good idea for you to try to put that into your calculator to make sure that you can get the correct answer as well. So we have 100 here. Let's get back to the pen tool. So we have 100 over 2. Remember again that we cannot divide the 100 by 2. We have to take the square root of the numerator first and then divide that number by 2. Okay. So 4 divided by 2 is 2. Plus or minus the square root of 100 is 10 over 2. So we have x equals 2 plus or minus 5. So again, I'll write it out as 2 separate parts, and if you can just do that in your head, more power to you, go for it. I'm just going to show all the steps. So if we have 2 plus 5, that's 7. Our next, we're going to take care of this negative here. X equals 2 minus 5, which equals negative 3. So what does this all mean? If we think about just a regular old graph of a quadratic, this quadratic would cross the x-axis at positive 7, so let's say that's maybe over here, and negative 3, so maybe that's about right here. And you may, I hope, remember when looking at this equation here at the beginning, the c term is the y-intercept. So 0, negative 21 is that y-intercept. So if this was 7 here, then our negative 21 is going to be way down here, and you can draw in your parabola, right? So the quadratic formula answers the questions, where does that parabola cross the x-axis? Okay, so our two answers are 7 and negative 3. So here we have a story problem. We're going to find the approximate solutions. In the shot put, an athlete throws a heavy metal bar through the air. The arc of the ball can be modeled by the equation y equals negative 0.04x squared plus 0.84x plus 2, where x is a horizontal distance in meters from the athlete and y is the height in meters of the ball. How far from the athlete will the ball land? So we're going to throw that into the quadratic formula. I'm just going to go ahead and grab this equation so I can write it down below and plug into the quadratic. So here's our equation. Let's give some space down here. And we're going to identify a, b, and c. So a equals negative 0.04. b equals 0.84. And c equals 2. So if we plug into the quadratic formula, we have x equals negative 0.84 over 2 plus or minus the square root of 0.84 squared minus 4 times the a term, which is negative 0.04, times the c term, which in this case is 2. Again, it's over, I forgot the 2 times negative 0.04 here. So we're going to put this over 2 times negative 0.04. Okay, so I'm going to throw this whole nightmare into the graphing calculator again, because I sure as heck don't want to do that in my head. So let's do 0.84 squared. Clear this out. So again, I'm going to use parentheses, 0.84 squared minus 4 times that negative 0.04 times 2. Close that parenthesis, start a new parenthesis, times 2, close that parenthesis. So some of you guys will freak out because we have these decimals, but who the heck cares because we have calculators. So we get 1.0256. So we're going to go ahead and continue this here. So I'm going to do this part in the calculator as well, then negative 0.84 over 2 times negative 0.04. So we're going to go negative 0.84 divided by, and then because we have 2 numbers in the denominator, I'm going to put that in parentheses, so 2 times, and again we're going to look back here, so 2 times negative 0.04. And then close that parenthesis. So the reason we have to do that is if we don't put the denominator in parentheses, we'll divide that negative 0.84 by 2 and then multiply it by 0.04 and get the wrong answer. So we want to divide that negative 0.84 by both these 2 numbers multiplied together. So we get 10.5 there for the first. So let's erase that. Got a couple little straight marks here. Okay, so x equals, again, that number was 10.5. So the reason this is a positive number is because we have a negative divided by a negative, which is a positive number. So 10.5 plus, and then we had that decimal when we multiplied what is called the discriminant here, and we got 1.0256. So let's go back here. So square root of 1.0256. And then we have 2 times negative 0.024. And we get negative 0.08. So over negative 0.08. So here's a funky thing about the quadratic formula. Because we have the plus or minus here, this negative doesn't actually matter, because if we do a positive times a negative, we get a negative. And if we do a negative divided by a negative, we get a positive. So this negative right here does not matter. Just a weird little wrinkle about the quadratic formula. So we have x equals 10.5. Remember, this is all about how far that shot put is going to land from where the person threw it. So plus or minus. I'm going to take the square root of that was a 6 right there, of 1.0256. So let's go back to the calculator and do that. So we're going to go second x squared and put in the 1.0256. See what we get there, which is, again, let's round to hundreds here. So if we look at the 2, that's in the thousandths place. Remember, it starts tenths, hundredths, thousandths. So the 2 is below 5. So we're just going to have 1.01 there. So 1.01 divided by negative 0.08. So I'm going to go ahead and do that in the calculator. I'm going to leave what I had in the calculator and divide it by the negative 0.08. So just divide by negative 0.08. So we're going to get negative. Again, I'm going to forget about that negative, round to hundredths again. So that 8, if it's 5 and above, you give it a shove, so that 5 turns into a 6. So we have 12.66. Again, I'm forgetting about that negative now. So 12.66. So we have 10.5 plus or minus that 12.66. So again here we've got two answers. This is what x equals. So x equals 10.5 plus 12.66. So let's go back in the calculator. 10.5 plus 12.66. Had an extra 6 there, but it doesn't matter. So 23.17 rounded. So 23.17. That's if we do the plus 10.5 plus 12.66. And if we want to do the subtraction, handy graphing calculator, I can just hit second enter. I'm going to delete these extra 6's. And then I'm just going to go ahead and switch this plus to a minus. Oops. Sorry, the calculator freaked out a little bit there, went too far. So 10.5 and change this plus to a minus. So we get negative 2.16. So x also equals negative 2.16. Okay, so let's go back and look at the original problem way the heck up here. And we're trying to figure out how far this shot put will go before it lands. So we have the two answers here, only one of which makes sense because he's not going to throw the shot put behind him. So this answer does not work. And then 23.17, I just want to check to see what the units are. And it's in meters here. So we're going to go back down. So 23.17 meters is the answer there. All right, next example. So we want to look at, again, we're choosing the appropriate method. Which method would you choose to solve each equation? We want to explain the reasoning. So if we look at these equations here, we want to figure out what's the best way to do it. So take a look at A, B, C, and D. If I look at A, right, I could add the 9 over, divide by 3. So 9 divided by 3 is 3. I could solve just by solving for x. This equation here, again, we can think about the cross. So we would have negative 30 on top, negative 1 on the bottom. So that one's just easy to factor. Now if we have kind of a problem here where you've got a number in front of the x squared, 13, just kind of ugly numbers, that one's definitely easiest to do quadratic formula. This one here, I would do quadratic formula. The book will probably tell us to do either quadratic formula or completing the square. When this b term is an odd number, it makes completing the square difficult. And again, I would plug this one into the quadratic formula. So if you go to the next page, you can see the detail here. So we're going to solve using square roots. When there's no x term, it's easiest to solve with square roots. The second one, factoring, as I said before, is a way to do that. This next one, the C, quadratic formula, you could also graph, but the equation cannot be factored. Okay, and then the D one here, we want the quadratic formula or complete the square, graphing, but the equation cannot be factored. If you think about the cross, 3 would be on the top, negative 5 on the bottom. The only factors of 3 are 1 and 3, and you can't get to 5. So I'd probably throw that one in the quadratic formula. And again, quadratic formula here. Graphing's kind of a pain in the neck. I wouldn't do that because the numbers are big and filling out that table will be a bit of a nightmare. So quadratic formula for these last 3 I think is the best way to go. Okay, so now we need to talk about the discriminant. As I said before, that's the part underneath the radical b squared minus 4ac. So the discriminant of a quadratic can be positive, 0, or negative. So if we go ahead and look at this next slide, you can see what happens. So if b squared minus 4ac is greater than 0, as in b squared minus 4ac is positive. So if you want to write it down like that, sometimes easier to remember. If what's underneath the radical is positive, that means we're going to hit the x-axis in 2 spots. If it's 0, what happens is that whole fraction, b squared, let me write the quadratic formula, try to write it up here, x equals negative b, when I get too close to the top, it likes to freak out, negative b over 2a, plus or minus, square root, b squared minus 4ac, over 2a. So when the b squared minus 4ac is 0, this entire fraction cancels out, and this is our one answer. So the parabola is going to come down and touch the x-axis and pop right back up. It could also come from the bottom, touch the x-axis, and go back down. Now if this is negative, because we can't take the square root of a negative number, that means that the parabola will never even touch the x-axis down here. Alright, I'm going to pause because I need to go get my charger because my computer's about to run out of juice. Give me 1 second. Okay, so as I said before, we can't take a negative square root, so that's why this parabola does not touch the x-axis at all. Okay, so if we have a positive number, we have 2 real solutions. If we have 0, there's only 1 solution. And if we have a negative number, no real solutions. Or as I always like to say, no soul. So if we just practice one of these discriminant-like problems, again we have this issue here because the number part is on the wrong side. So I'm going to add 5 to both sides to start. When you do this discriminant, it's a heck of a lot easier than the quadratic because the only part of the quadratic we're doing is the part that's underneath the radical, b squared minus 4ac. So if we plug that in, first here we're going to do this 2x squared minus 3x plus 5 equals 0. I'm just going to erase this and we're going to plug into the b squared minus 4ac. So b squared minus 4ac. So again, we have a negative here, so make sure you plug in using parentheses. So negative 3 squared minus 4. The a term is 2. The c term is 5. And we can go ahead and plug that entire thing into the graphing calculator again. So negative 3 squared minus 4 times 2 times 5. We'll clear this stuff out. So again, using parentheses, negative 3 squared minus 4 times 2 times 5. So times 2 times 5. And there you get negative 31. Move down a little bit. So we get 9. I'm just going to show some of the math as well. So 2 times 5 is 10, times 4 is 40. So 9 minus 40, negative 31. Again, if we have a negative under the square root, that's what the discriminant tells us. Negative under the square root, we have no soul. Alright, so positive number, 2 solutions. Negative number, no solutions. If you get 0, when you do the discriminant here, you just get the 1 solution. Okay, I don't really think we need to do another one of those. There's your homework. I will have it posted on Schoology for you. I know this lesson was a little bit long. I switched to something called the snowball microphone, so I hope the audio quality is a lot better than the first video I posted. So I'll go ahead and use the snowball microphone from here on out. Alright, take care of yourselves. I look forward to seeing you all on Block Day. Come with problems you had questions with, and we can all work on them together in a Google Hangout. I'm going to have everything published Monday morning for you. So that is it. Have an excellent day, week, and we will talk to you all on Block Day.